Hi folks, today on 1 Minute Math we're actually going to be looking at a computer science topic. I'm going to briefly discuss the idea of variables in the context of computer science. This would be geared toward a beginning coder, someone in an intro level code course like AP Computer Science Principles or some other intro level course. The code that I'm going to be writing today will be in JavaScript. It's easily transferable. If you're used to coding in Java, JavaScript will just feel like a lighter version with a little bit less structure. Right, so variables. A quick note about variables, and then let's see how this plays out in the context of a particular assignment or a problem that we might be trying to solve, and we'll also see a few ways that this can be tricky in multiple choice questions on tests or quizzes. All right, so the idea of a variable in computer science. When I make a variable, and here I'm in JavaScript, I'm going to use var. I could use let, but I'm going to use var to kind of highlight the fact that I'm making variables. If I name a variable, I'm going to call it num. Okay, I'm going to start with a variable called num because it's going to be a number. I have now essentially created a bucket that is named num. Okay, now I've got this bucket and I've decided that it's going to be called num. There's nothing in it. It holds nothing. I've just created it. If I want it to have a value, if I want to put something in my bucket, I use a single equal sign. And for right now, let's just say I want num to contain the number 1. So now into my bucket called num, I'm going to put, oops, there we go. I'm going to take the number 1 and just plop it in there. So if I print out, print line, the number is num. If I run this, it's going to say the number is 1. Not the number is num. Num is the name of the bucket, but when I call num in the code, it's going to look in the bucket and see what's in there and be like, oh, it's 1. So if I try this again, if I want to update the value, now I want to update the value in my bucket. I do not want to make a new bucket, so I'm not going to write var again. I'm just going to say, oh, now I want num to have the value of 5. Okay, and I print it again. The number is num. Now it says the number is 5 because when it looks in that bucket the second time, the number that's inside is now 5. I've dumped out the 1 and I decided I was going to put a 5 in there. And we're allowed to do that. We're allowed to reassign values inside variables as much as we want, assuming that it's the same kind of like the same type of data that we're putting in there. If I started with a number, it should be a number. That makes a lot better sense when you're in Java than you're in or C++ than in JavaScript or Python, but we're not going to split hairs about that right now. Okay, so here's my num. Now let's say this single equal sign represents assigning a value. That's like putting something in the bucket, okay? If I want to check what's in the bucket, that's when I use a double equal sign. So if I want to check, is the value in the bucket equal to 6? And if it is, let's print yay. And if it's not, let's print, I don't know, no way. Just so we can see the difference here. Now when I run this, oh, no way, it's not 6. If I reassign value, if I update the value of num to be 6 and I try this again, now it gives me the yay, okay? I've dumped out the 5, I put a 6 in the bucket, it looks in the bucket. Equals equals is trying to look in that bucket. You can imagine, imagine that you've got some funky sunglasses, okay? The equals equals is like the guy looking into the bucket to see what's in there. It is not an assignment equal sign. It's not a putting a value in equal sign or setting a value equal sign. It is a checking a value equal sign. Now, let's go ahead and talk a little bit about how this plays out if I move things around. I'm going to put a couple more variables in here, and a classic way that these, let's call this A, B, and C. A classic way that these problems come up in multiple choice questions is to follow what happens to variables. So I'm going to set A as 1, B is 2, and C is 3. And let's just follow what happens if I move things around. Okay, so now I'm going to say A gets B, B gets C, and C gets A. All right, and the question is, if I print out C, what am I going to get? Before I run this, let's try and imagine what's happening with our buckets. I initialized 3 variables. I made 3 buckets. So one's called A, one's called B, and one's called C. There they are, my lovely little buckets. And I have decided that the values that I'm dumping in them to start with, I'm going to put 1 in A, I'm going to put 2 in B, and I'm going to put 3 in C. So those are the values that are living in those buckets just for this moment, right? Then in this next part, in line 7, 8, and 9, I'm just switching the values around a little bit. I am putting whatever was in B, so B is like, we look in there, we see 2, I'm going to put that in A. So now A has 2 in it. B still has 2 in it. I just kind of like made a copy and put it in there. I don't actually like dump the stuff out of B. I just dumped the 1 out of A and put B in it. Now B gets whatever was in C, so B's going to get 3. Okay. And C gets what is in A. And now currently what is in A is 2. So 2 is going to go into C. And if I check what C is, if I run this, we should see 2. Bam. All right. Well, if I give code like this on a multiple choice test or anything like that, the classic question is, well, why isn't it 1? A was 1. But remember that A is just the bucket. A is not permanently 1. A is the name of the bucket that started by holding the value of 1, but that value can change a lot. Okay. So if we look at some questions, take a quick peek at some questions here as they would appear on a test or quiz. The first one might say, I'm trying to switch the values of A and B. Will this code switch the values of A and B? So let's see what happens. If I start with my 3 buckets, I start with an A, a B, and a C, or in a temp rather. Temp. And I'm going to give them values to start with because I think it's easier for me to follow this kind of code if I'm talking about actual numbers. So let's say it started as 1, 2, and 3. Okay. And if this switched them, our goal would be to have 2 in A and 1 in B when I'm done. So that's our goal right there. Let's see if that's what happens. All right. This says B goes into A. So now A is holding 2. A goes into temp. So now that's also holding 2. And then A goes back into B, which is now holding 2. Did I effectively switch A and B? And the answer here is no. If I really wanted to switch A and B, what we could have done, erase, there we go. Let's see if we can figure out how to effectively switch A and B. If I started with 1, 2, and 3, I want to dump A somewhere. I don't want to put B in A, but I need to hold the value of A somewhere for the time being. And let's use temp for that purpose. Temp, usually when you make a variable named temp, you're going to use it as a temporary holding spot. So let's give temp A, which if you're coding, you could say temp equals A. Okay. Now A has gone into temp. Now I can put B in A. So now A can get 2, and that value that had been in A, which is now in temp, is conveniently waiting for me. I can put that in B, and that will effectively switch A and B. That's how you use a temporary variable to do that. You can even do that right here. I'm going to go ahead and call this temp, and let's see if we switch our code here. Let's print line. We'll do A first, and then we'll do B. So what do we say? Temp gets A gets B, and B gets temp. A ended up as 2 and B ended up as 1, just as we expected. Cool. This is another kind of thing that often happens, and the question on this one is, we were intending to add up all of the numbers between 0 and I. We were given an I, and we want to add up all the numbers between 0 and I, and we're supposed to get that sum, like the sum is supposed to be that in the end. We're supposed to evaluate whether or not this code works, and maybe you've figured out already what this code is going to do. But let's go ahead and see what happens here. We're just going to follow this as it goes. I starts as 0 and sum starts as 0, and let's go through every single step. We're supposed to repeat this until I equals 4, so it's like a while loop. While I is less than 4, we're going to keep doing this. So the first thing that happens is that I gets 1, and then sum gets sum plus I, so that's going to be 1. Now I moves up to 2. Now we go back to the top of my code, and I gets 1. Do you see what's going to happen? Sum gets sum plus 1, which will be 2, and I goes up by 1. But then I go back to the top of my code, and I gets 1, sum goes up by 1. Am I ever going to get I to equal 4? I hope you see that we won't. To fix this code is entirely broken. To fix it, I need to stop initializing I inside that loop. If I take that step out, now we can follow this along and it will be much nicer. I begins at 0, sum begins at 0. Let's start as sum gets sum plus I, so it's going to be 0 again. And then I gets 1. I goes up by 1. I gets I plus 1. Now sum gets sum plus 1, and I goes up by 1. Sum will get sum, which is 1, plus I, which is 2, and I goes up by 1. Then sum gets sum plus I, which will be 6. I goes up by 1, and I'm done. So this would work. I'd have to evaluate whether or not I'm supposed to include the 4 or not to answer the question of whether or not I'm actually getting the sum. But this one works much better. The problem originally was that I was sticking something in that bucket that I didn't really want to do every time. I wanted the value that was in there to not be reset every time to 1. Okay, final thing we're going to do here. I'll go down here and give myself some stuff to write. A classic coding challenge is to write a for or a while loop that will give me the Fibonacci sequence. If you're not familiar with the Fibonacci sequence or Fibonacci numbers, we start with 2 1s and we get the next number by adding the ones that we have, like the previous 2. We just add the previous 2 numbers. 1 plus 1 is 2, and so my next Fibonacci number is 2. And then to get the next number, I would add those 2, and I get 3. And then for the next number, I would add those 2, and I get 5, and so on and so forth. Can you predict the next one? Good. Hopefully you said 8. And this is how the Fibonacci sequence goes. Let's write a for loop over here that's going to give me the first 10 Fibonacci numbers. Okay. So somewhere down here I want a for loop. That's just to loop through this 10 times. I'm going to need some variables. Let's call them first num and second num. So I start with a 1 and a 1. It's probably going to be handy for me to have a third num. Yeah, let's go ahead and make that. I'm going to call it the sum. I'm going to call that first num plus second num. So right now I've got 3 buckets going. And in that first bucket, which I'm calling first num, I've got a 1. In that second bucket, which I'm calling second num, I've also got a 1. And I've made this third bucket, which is currently just holding 1 plus 1, but I've called it sum for a reason. I think that this is its goal is it's always going to be the sum of the first number and the second number. And let's go ahead and imagine what we want to do with these numbers. Like right now, sum is going to hold the number 2, and you can see I've got the first 3 numbers in line here. In fact, I could even print. Let me go ahead and print. Print first num and second num. I'm not going to print the sum in there, though. I'm going to print the sum in here. So right now I'm printing the 1 and the 1, and now I'm printing the 2. And 10 times I want to recalculate a new Fibonacci number and spit it out. So to get the next number, if we imagine our process up here, we did the 1 plus the 2. That would be like what I currently have in second number plus what I currently have in sum. So it's like I'm saying now this is the first number and this is the second number. I want to give those values new names, or maybe I could think of that as saying I want to take the buckets that I have called first and second and put new values in them. So what was in second num, I want to be in first num. First num gets second num. What was in sum, I want to go into second. And I need to reevaluate sum to be first num plus second num. So this happens a lot. Ms. Thomas, we already said that sum was first num plus second num. Yeah, we sure did. But we didn't, when we declared that sum was going to be first num plus second num, first num and second num are both equal to 1. And once we've updated those values, we need to tell the computer, we need to tell the program that we want to reevaluate that sum. If we don't tell it to reevaluate the sum is always going to be first num plus second num. Let me go ahead and run this and see what we get. Fantastic. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144. Those are all the Fibonacci numbers. So for 10 times, it is scooching the names over or scorching the values down, depending on how you think about it, so that we're reevaluating the sum by the sum of the previous two things. Hopefully this cleared up a little bit of variables for you. It's really important to get your head around using variables in computer science, and keep practicing at it, keep working at it, you'll get it.